So today in lesson E6, up to this point, our whole part of this unit has been on what is a function. If it's a function, each input has one output. Now we're going to look at the difference of linear and nonlinear. So we're going to kind of be more specific. So the second half of the unit, when we look at our poster for your test, determining if it's a function, writing a story. Now we're going to be looking at the linear, nonlinear, and then we're going to look at properties of it. So the next couple days, that's going to be our focus. So understanding a relationship and distinguishing between rate of change is the same as what other word did we use for rate of change? That's the same as our what in the last unit. Anyone remember? Slope, right? Our intercepts, we talked about the y-intercept, always on that y line, right? So we talked about y-intercepts. We're going to talk about linear and nonlinear. Linear just means it makes a straight line. Nonlinear, it's not a straight line. And then we're going to look at some different figures of different ways that they're represented in tables, graphs, and equations. Do you recognize this form of our equation? Y equals to mx plus b. That was our slope-intercept form. So what is a function? Just a little bit of review. What is a function? What I'd like you to put down is, in a function, is any relation where one input has exactly one output. So relating pairs where one input has exactly one output. It doesn't matter if there's a pattern or not. Just each input has one output. That means if I input 2 and I get out 4, I can't input 2 and get 7. Every time I input 2, I have to get the same output, okay? So a functions have special name. When we talk about functions that have special names, what we're going to be taking a look at. In 8th grade, our main type of focus that we've been looking at have been linear functions. Linear functions, we're going to talk about the special features of those, but the other types of functions that we are going to be looking at this year are going to be called nonlinear functions. So those are our 2 that we will focus on this year. Next year in algebra, huge focus again on linear functions and getting some into that function. It has a constant rate of change. That constant rate of change, often called our slope. Then the graph is a line, no curves. The table shows repeated addition. Now, it could be repeated subtraction, because remember, subtraction is when you add the opposite. So adding -2 is the same as subtracting 2. Equations are going to be written in this form, y equals mx plus b. Any exponents or variables or dividing by a variable means it's nonlinear. This is really big, okay? This is one that students sometimes miss. If you have an exponent, what are my exponents here for the y and x? They're understood to be ones. We don't write them in. So if you have a variable, if you have an exponent other than 1, or you're dividing, what does dividing look like? It might be something like this. Y equals 4 divided by x. That is going to be nonlinear. Okay? Any function that is not linear is called nonlinear. Some nonlinear functions have special names. Like this one right here is a parabola. We're going to get into that next year in algebra. This one is exponential. Okay? We'll be doing that this year also, some exponential ones. And here, if we look at our equations, right, all the variables are to the first power. We rewrite it in slope-intercept form. When we graph it, we have a nice straight line. Here, y equals -2. If we want to think of it in slope-intercept form, the slope is 0. Nice straight line going across. So anytime you have a straight line, it could be vertical, it could be horizontal, it can be slanted. Now, vertical lines are not functions, right? But they are linear. So if it's a vertical line, anytime it's a straight line. So when we are taking a look at those. So this next page, we want to be looking at tables. And we're trying to decide if they are linear. Okay? So a linear function or not a linear function. Okay? So when you write below them, if you want to write linear or nonlinear, you can write that out. And what we are looking for is constant addition or subtraction. So in this first one, I noticed that my x's are going up by 1s. So how are the y's changing? The first one is a plus 3. Is it always plus 3? Yeah. So this is going to be a linear function, right? If I look at this one, my input or my x's are going up by 1, 3, 4, 5. Oh, but then look down here, we got 4 and we got 4 again. So right away, I notice that it kind of starts going up by 1, but right away, 4 gives me 7 and 4 gives me 14. Is it even a function? This one is totally, it's not just the linear, non-linear function, it is not a function. This one is not a function. So you need to be careful. Sometimes it's really easy to just get caught up in the linear, non-linear, and forget, oh, that doesn't even make sense. That's not a function. Because 4 had 2 different outputs. So here we look at our x's. Okay, they're going 0, 1, 2, 3. They're all unique. And here we're going to look at our y's. From 43 to 32, we are doing what? Subtracting 11. Do we do that again? Someone said, oh, I could add a negative 11. There's constant addition or subtraction in this one. That looks to be the case every time. So this one is going to be a linear function, right? I want you to take a look at these next couple of tables and just try and decide if you think it's a function or not. And then the next thing I want you to decide is, do you think it's linear or nonlinear? So I'm going to give you, talk to someone. Talk to someone. People right by you, talk to someone and figure out. See if you agree or not, okay? So just the first one I'm looking at. What would you tell me? Not a function. Why not a function?
-2 has 2 outputs.
Nice. -2 has 2 outputs. Right here is my reason for not a function. -2 has 2 outputs, okay? If I look at that next table, Hunter. Not a linear function, because what's happening? Here you went up what? 2. Then what, Hunter? Then we go up 1, then we go up 10. Not linear. I agree. And because it's not constant. So, we're now looking at that last one, and Sam, what would we say? So if we're looking at this one, you're thinking nonlinear as we were looking at it? So if we are looking at this one, -3, here we're going up 3, right? Then we go up, where this is going up 3, we're going up 12. So definitely my fault in telling you one of them had to be linear. These last 2 are both nonlinear. Okay? So, nice job picking out the not a function. So, I think the tables are kind of the harder part. The equation, or the graphs, are a little easier. So, what we are looking at here is we want to say again, linear function. Linear function means each input has 1 output. So, pretty easy to identify our nice straight lines, right? The second one, and what other one? On the bottom, the first one, right? This one is going to be linear. These are my 2 linear functions, right? If I'm looking at nonlinear, there are 2 of them. What are my 2 nonlinear, if you were going to identify? What is one of them?
It would be the first one, like a triangle type thing.
This first one being, this one is not nonlinear. It is kind of not a straight line, but it's actually not a, it's not a function. This one is not a function. And the reason it's not a function is, look, if I draw this vertical line, but at this point, at 3, I have 2 outputs. I have 3 and -3. At 1, I have 2 outputs, 1 and -1. So, since we've identified our not function, is there another not function? Okay, let's do not function first. Can you do the not function for me? This very last one. This very last one is also not a function. Okay? Dan, you were looking at nonlinear. Which one did you see? The ones that are left. These 2 are both my nonlinear. Okay? These 2 are both going to be nonlinear. because they are still functions. Each input, each x only gives me one output. Each x value that I put in gives me one output, but they don't repeat at all. So I think graphs are the easier ones, and anytime you have it where it goes through 2 points for that x value, not a function. Okay, so just be careful for those. All right, so now we're going to look at equations. And the equations, the key thing we read in the definition said, when you look for a linear and nonlinear equation, we need to check that the variables are to the first power, there's no division by the variable, and there's no exponents. So, I want you to go through and, in this case, as we are looking at these, I want you to write all the ones that you think are linear functions. I just want you to put an LF behind each one that you think is a linear function. The key definition, variable to the first power, can't divide by a variable, no exponents. So, I want you to just take a look really quick. Let's take a look at the first one. Kendall, what do you think? Linear. Other linear functions that you could tell me, Rajad, what's another linear function? Y equals 10 is a linear function. Linear function for y equals 10. Anyone, if we're looking for another one, Grace. Say it one more time. 3, square root. I'm going to show you on the Desmos calculator what that looks like. Okay, so if I put that in, and I put in y equals, and kind of goes like this. If our equation was 3 square root of x, so we change it, y equals 3 square root of x, it looks like that. So when we are trying to decide function or not a function, definitely not a function. So if I'm looking for another one, Aaron, what do you think is another linear function? Linear function. Okay. If I'm looking for another one, Matt, I believe there's at least one more. Y equals 3. The x here, we don't write this 1 and we don't write the 1 here. It's always just understood. This is definitely a linear function. So I just want to show you what some of these other graphs look like so you can picture what they look like as we look at that Desmos calculator. So that was the 3 square root of x. We are going to put in our y equaled 4, and then it was 4 times parenthesis 2, and it had an exponent, so it was 2 to the x. So writing it like this, and then I click on the x up here, outside. Ooh, let's see. We're going to go back here, and we're going to go here to the x. And y equals, so let's check this. You can always kind of check it and see, but anything that has an exponent or a power other than 1, and if we zoom on our graph in, or if we zoom way out, and I now change this number to 17, you're going to see that the 17, it moves it up on this axis. So when we are looking at those and we're trying to decide function or not, linear or nonlinear, remember you could always check kind of on that Desmos calculator and just put that equation. So our other nonlinear functions, let's make sure we put those ones down. This was nonlinear if we were looking at it, right? So our nonlinear function. This is going to be a nonlinear function, nonlinear function, nonlinear function. All of them were functions. What one would not be a function? X equals 2 is not a function because every input gives me an output of 2. Okay? So when we are looking at that. So Next, this is what you'll see on the test. I give you a question kind of like this where we look at a table and I ask you to make this relationship. So here's the key thing and you're going to be doing this project that kind of looks like this also. So we start off with the number of rectangles and we have one rectangle. And the most common thing is to put 1 here. I want you to start with 0. 1, 2, 3, and we have 4 rectangles. Now on the test it kind of looks like this, and I ask you to look at these. And in this one it says, what is the relationship between the number of rectangles used in each figure and the perimeter? So we're starting with 1 rectangle. At 1 rectangle, what is our perimeter? 6 plus 1 plus 6 plus 1 gives us 14. Behind the 1, please put 14. Don't put it behind the 0. Because this is when we have 0 rectangles. And the most common thing is people go, it has to be 0 perimeter. But we got to be careful because we're looking at a pattern here, okay? So, at 2 rectangles, we have 6 plus 1 plus 1, another 6 over here, and 1, 1. What are we looking at for our perimeter of this one? We should have 16. Notice you just really added these 2 1s at the top and the bottom, right? So the next one, for 3 rectangles, we should have 18. And we might not even count for 4, but we would have 20. So we're looking at it. Now we've made the table. We want to make the graph. So making the graph, at 1, we're going to go to 14. At 2 is 16. 3 is 18. 4 is 20. If I asked you to do 5, what would you think 5 is? 22. Now, we are not going to connect these with a line. Why? Because, like if I have 1.5 rectangles, do I have 15 for a perimeter? Does that make sense? So this isn't really a straight, this isn't continuous. This is called a discrete graph. Okay? So you can get into that vocabulary later. But if I had 0 and I had to go back, this is my really important point, right? Remember, when x is 0, so put up at the top here, this is x, this is y. When x is 0, that's called my what? When x is 0, the y value is called my y. Anyone? Y what? Y intercept. Thank you. So if I go back, right, this is adding 2 each time. If I go back, this is going to be 12. Oh. So I want to write an equation. What does my equation look like? Slope intercept one. Oh, this is my important point, right? This is my y-intercept. That's my b, right? So that's why we did that whole last unit with the y-intercept and b, okay? What is my rate of change? So we're going to have y equals, how much is it changing each time? Plus 2, right? So y equals 2x plus 12. How do we get the 12? The 12 comes from our y-intercept here, okay? How do we get that rate of change? That rate of change, that's our plus 2, that goes here, that's our slope. And if we are looking at our 0 number, anytime I look at that 0, so 0, 12, that's the number that goes in here. So it says analyze your model. First off, is it a function? Would we say it looks like a function? Does it look like a function? It actually looks like what kind of a function? Linear function, right? So I don't know that you need to have all of this totally written down, but you could probably go with it is a linear function, okay? Because you add a rectangle to each picture, so you're adding 2. A reason you can always give me is we had repeated addition. And the other reason that it is a linear function is we had a straight line when we graphed.